Good afternoon, students. So in the last class we discussed the operation of shift register, and we have also seen what are the different categories of shift registers, right? And how they are classified and their operation, right? So in today's class we will discuss the universal shift register, right? So you can use only one IC to perform all the operations what we discussed in the last two classes. Okay, so that particular shift register is called universal shift register, right? So you can load, you can shift right, you can circular shift, you can shift left. All these operations can be performed by using only one IC, which is called universal shift register, right? So before we see this universal shift register, what we will do, first we will see what all operations it can perform, right? So in the form of a table, right? So here so in this universal shift register, along with D flip-flops, which is a very simplest flip-flop, right? Using that D flip-flop, we can also use multiplexers, right? So why multiplexers are needed, that you will come to know when I discuss this table. Okay, so before actually we see the universal shift register circuit, we will see this table first. Okay, here I'll consider two inputs, S1 and S0. Okay, why I am considering S1 and S0? Because I am making use of multiplexer, 4:1 multiplexer, right? And we have also seen we have already seen the select lines of multiplexers are denoted as S1 and S0. Here we are using 4:1 multiplexer, right? So S1 and S0, and data line and the operation, right? So these four information we will see. We will include these four informations in a table, right? And we will discuss the different operations performed by universal shift registers, right? So here we have two inputs, S1 and S0, where S1 is MSB, S0 is LSB, right? So with the two inputs I can write four different combinations, 0 0, 0 1, 1 0 and 1 1, right? So when 0 0 select line is 0 0, the multiplexer is going to select the data on the data line D0, right? And when it is 0 1, it is going to select D1. When it is 1 0, it is going to select D2, data on D2, and when it is 1 1, it is going to select D3, right? So what are the operations, what are the different operations that this universal shift register can perform when select lines are 0 0, 0 1, 1 0 and 1 1? The first operation is hold, that it is going to hold. That is like no change in the what you can say, in case of flip-flop we have a state called no change, when S equal to R equal to 0, right, and J is equal to R, K is equal to 0, and in case of T flip-flop when T is equal to 0. So that is also called as a no change state, or that is also called as hold state, right? Second one, shift right. When select line is 0 1, we are going to perform a shift right operation, right? And when it is 1 0, we are going to perform shift left operation, right? And when it is 1 1, we can also load, the data, right? So these all operations we have discussed with the help of four different circuitry, right, in the last two classes, and in today's class we will use only one circuit to perform all these operations, and whatever operations I explained in the last two classes, that can be done using only one shift register. Okay, so now you just remember this table. When select lines are 0 0, it is hold state. Next, when it is 0 1, it is shift right, 1 0 shift left, and 1 1 it is parallel load, right? So what we will do first, we will step by step we will see that whole universal shift register circuit, right? So here I will not explain all four states, all four operations, so at the same time. So first we will try to understand one operation first, then we will verify all four operations at last. Okay, so moving to the next slide. So here again we are going to use 4D flip-flops, right? But the connection is not going to remain same as we discussed in the last class, right? So we are going to use 4D flip-flops, right? Just draw them. 4D flip-flops. Inputs I will draw. Okay, I will not readily make the connections. Okay, I will just keep everything ready and later I will make the connections. Okay, D3, Q3, and this is D4, Q4. Okay, now clock is implied, clock is there. At last I am going to connect that clock. Okay, so I said already, along with these D flip-flops we are going to use 4:1 muxes, right? So 4:1 mux has two select lines, as we have already discussed in the second module. Okay, so it has 4 data lines, D0, D1, D2 and D3, and it has 2 select lines, S1 and S0. Okay, so now these are 4 data lines and it has only one output. This is 4:1 mux. The output I'll denote it as F, right? Similarly I'll draw first all 4:1 muxes. So now here all select lines are shorted, right? So these 2 select lines are shorted here, right? So because we are using 4:1 muxes, right? And here each mux has 2 select lines, right? And we are going to short all those select lines. That means the common select lines are going to act. That means select lines are going to act as a common for all those 4 multiplexes, right? So now based on that table, now we will make the connections, right? So when select line is 0 0, when select lines are 0 0, what is the operation? It is going to select D0, and what is the operation? Operation is hold. That means all flip-flops are going to hold their previous state, right? So how can I do that? Now where this output needs to be connected, this output needs to be connected to D1, right? Because the output of mux has to be connected to the input of multiplexer, right? So now I'll connect. Before that, before connecting this, we will understand how can I make this flip-flops to hold their previous state, right? So let us see D1 is equal to 0, right? So I'll apply the clock pulse, right? So what will be the value of Q1? Q1 will be equal to 0, right? Q1 will be equal to 0, right? So now if I want to hold this state, so irrespective of the number of clock pulses, right? How can I do that? I need to connect this Q1 to D1, correct? So whatever you do, you can apply infinite number of clock pulses. If I connect Q1 to D1, if I connect this Q1 to D1, even if you apply infinite number of clock pulses, the first flip-flop is going to remain in its previous state. Let us say initial state is 0 0 0, right? So it is going to remain in its previous state even though you will apply infinite number of inputs because of this short, right? So instead of doing this, so this operation needs to be performed only when select lines are 0 0, right? So when select lines are 0 0, it has to perform the hold operation. So instead of connecting Q1 directly to D1, I'll make use of this flip-flop because S1 and S0 are connected to the multiplexers. Sorry, I said flip-flop. I'll make use of multiplexer, right? So here S1 and S0 are connected to multiplexer, right? So when S1 and S0 are 0, it will select D0. That means this Q1 has to be connected to D0, right? So instead of directly connecting Q1 to D1, what I'll do, I'll connect the output of mux to D1 and output of this flip-flop to D0. In that case, what happens? When select lines are 0 0, it is going to select D0, and to this D0 I am connecting Q1. That means Q1, instead of connecting Q1 directly to D1, I am connecting through this mux, right? So what I'll do, I'll erase this connection now. I'll erase that connection now, right? So instead of connecting this Q1 and D1 directly. What I'll do, I'll connect it via what? Via a multiplexer, right? So Q1 I'll connect it to D1, D0, and F will be connected to D, right? It is one and the same, right? See now, if S1 and S0 is 0 0, and if my previous state is, let us say, 0, if my previous state is, let us say, 0, that 0 is connected to D0, and when select lines are 0 0, it will select D0, and output will be equal to the value of D0, and if it is 0, then D1 will be equal to 0. In that case, Q1 will also be equal to 0. That means this flip-flop is going to remain in its previous state, right? So let it be whatever may be the previous state. It may be either 0 or 1. It is going to remain in its previous state. Similarly, this connection is going to remain same for all the flip-flops, because all flip-flops need to hold their previous state when select lines are 1 1, right? So what I'll do, now I'll connect this Q2 to that respective mux, right? So I have 1 1 mux for each of the flip-flop. So I'll take the output of Q2, output of each mux, and I'll connect it to D0 of each mux, and output of multiplexer is connected to input of that particular flip-flop. Similarly, Q3 I'll connect to D0, and F needs to be connected to D3. Similarly here, Q4 is connected to D0, and F is connected to D4. Clear? I hope this connection is clear. Okay, next, second operation, when it is 0 1, when it is 0 1, instead of going to select second operation, we will go to the last operation, that is 1 1. When select lines are 1 1, operation is parallel load. Operation is parallel load, right? So for parallel load, when select lines are 1 1, multiplexer is going to select the data line D3, right? So what I'll do, I'll not connect them anywhere. These will act as the parallel inputs. D3s are going to act as parallel inputs, right? So first, when you are trying to load these 4 flip-flops with some data, right? So we will keep S1 and S0 is equal to 1 1, and we will keep the parallel load on these D3s, on these pins, right? On these pins. If I keep those pins, if I keep the data on these pins, the flip-flops will be loaded with that data, and if I make S1 and S0 is equal to 1, right? So now these are the 2 operations. Now we are left with only 2 operations, that is shift right when it happens when select lines are 0 1, and when it is 1, when select lines are 1 0, the operation is shift left. Okay, so now first we will see shift right? So first we will load some data. Okay, so what I'll do, I'll make S1 and S0 is equal to 1 1. I'll load some data. Okay, let us say data is equal to 1 1 1 0, 1 1 0. I'll keep this data on these D3s, right? And I'll load, I'll make S1 equal to S0, and I'll apply the clock pulse. I'll apply the clock pulse to all 4 flip-flops synchronously at the same time, right? At the same time I'll apply the clock. So what happens, when select lines are 1 1, it is going to select D3, and F will become 1, this F will become 1, this F will become 1, this F will become 1, and this F will become 0, and these datas get loaded into these 4 flip-flops. Clear? I think it is clear, right? So what is the data here? It is equal to 1110, right? So now what I'll do, I'll shift right. Otherwise, before going to shift right, we will see the first operation, that is hold, right? Whether with this circuit, whether the flip-flops will hold their data or not. Okay, now suddenly I'll make S1 equal to S0 equal to 0, and I'll apply the clock pulse to these flip-flops, right? So what happens now, since Q1 is high, because D1 was high, and Q1 was high, right? So Q1 is connected to D0. That means when I make select lines as equal to 0 0, multiplexer will select the data on D0, right? So what is data on D0 here? It is equal to 1. That means the output of mux will remain 1, and D1 will be 1, and Q1 will remain 1. That means this flip-flop is holding its previous value. Similarly, Q2 is equal to 1, because F is 1, D2 is 1, Q2 was 1. That was the previous state of the second flip-flop, right? Now Q2 is connected to D0, and select lines are 0 0. See, we have shorted all the select lines. Select lines of all the muxes are shorted, right? So for that reason, all the muxes will hold the data. All flip-flops will hold the data, right? Now Q2 is 1, Q2 is connected to D0, and since D0 is 1, F is equal to 1, which is connected to D2, and Q2 will become 1. That means it will hold its previous data. Similarly, you can clarify the second, third mux and fourth mux operation. Okay. Next, we will see shift right operation. Right. For shift right operation, what should be the value of select line? S1 should be 0, S1 should be 0, and S0 should be 1. S0 should be 1. So when I make S1 equal to 0 and S0 is equal to 1, we are going to perform universal shift register is going to perform shift right operation, right? So to shift right operation, what data I need to load in this, right? Initially, because this data will be shifted towards right, it will go out, this 0 will go out, and this 1 will shift here, this 1 will shift here, and this 1 will shift here, right? So what data I need to load in this first flip-flop, right? So that can be done using the second data line, that is D1 in this mux, right? So here what I'll write, serial in data for shift right operation, right? So if I make this input is equal to 0, what happens? This 0 comes here, and when I select line is equal to 0 1, F will become 0, and this 0 will be loaded in first flip-flop. And what happens to this 1 will get shifted towards right. So how can I make that connection now? See, this D1 gets loaded in first flip-flop, and Q1 will become equal to 0, right? Q1 will become 0 means 0 will be loaded in this, right? So this one needs to be shifted towards right? So this flip-flop is holding this data, right? So this data, right? So previous state of the flip-flop or previous data of the first flip-flop, that needs to be shifted towards right. So how can I do that? Right? So for shift operation, I am using D1, right? So what I need to connect to D1? Here I need to connect Q1, which was the previous state, right? So this Q1 needs to be connected to D1. So what happens? Previous value of Q1 was 1, right? So that 1 is connected to D1. That means F will become 1, and this data will be, this flip-flop will be loaded with 1. Which one is this? It is the one which was stored in the first flip-flop. Clear? I hope it is clear. If it is not, so please rewind the video and see. Okay. Similarly, Q2 needs to be connected to D1. That means the flip-flop, previous state of the flip-flop, this state of the flip-flop or data will be shifted towards right. Next, Q3 needs to be connected to D1. Right? So what happens here? The previous state of this flip-flop will be shifted towards right. So what happens to 0? 0 will go out, right, through this line, right? So here you can say this is serial out. So the next operation I will explain in next slide.